All right, when we left off last time, we were looking at this problem where we were solving for x, and we ended up getting plus or minus the square root of negative 16. We said you can't take square roots of negatives, and so we answered with the fact that this one would have no real solutions for x. However, what we're going to look at today is there is a way we can answer this with a new kind of number that we haven't seen before called imaginary numbers. Okay, imaginary numbers were first brought up by Rene Descartes back in the 1600s, and he said that we could take the number I, so we're going to use this letter I here to use for an imaginary number, and it could be defined that I squared be equal to -1. Now, if you think about that, that up until this point wasn't possible because if we were to take the square root here of both sides, we get that I equals the square root of -1. And we've talked about you can't have square roots of negatives, but if we say that you call that I, then you can do some more stuff with numbers that weren't possible before. So anytime you get square root of a negative of -1, we're going to say that that's going to be equal to I. Let's look at an example. Let's say we have this problem right here, that x squared plus 2 equals 0. Well, what we're going to do is solve it similar to this other problem we were doing up here to find x. So we're going to start by subtracting 2 from both sides. So we have 2x squared equals to -2. We'll divide by 2. We're trying to get x by itself. After dividing, we got x squared equal to -1. We're going to take the square root of both sides, so x is going to be equal to plus or minus the square root of -1. Well, what do we know square root of -1 is equal to? Square root of -1 is equal to I. So what we're going to say for this is that our answer for x is plus or minus I. And that would be our solution. So we can answer and say that our answer is plus or minus this imaginary number I. We could now finish, if we want to, go back and finish this problem we were doing before and maybe come up with a solution here. So let's come back to this problem. If we keep going on this one, what we would do next is say, if you have a negative right here under the square root, this negative sign that's under our square root, we're going to take that and pull it out as I. Now what we can do is simplify that radical. Square root of 16, we've seen this one before. We know that that is equal to 4. It's a perfect square. So our answer on this one becomes plus or minus 4i. And that would be now the solution. So there is not a real solution, but there is what we call an imaginary solution. These are also called, anytime you're involving imaginary numbers, it's also called complex numbers, because complex numbers are numbers that involve real parts and imaginary parts. All right, let's look at some other examples then. On number 3, they want us to simplify square root of -18. All right, anytime there's a negative under the square root sign, there's not going to be any real answers, but we can get an imaginary solution. So that's what we're going to be using on this one, is we're going to come up with an imaginary solution. So on this one, what we do is we start by taking this negative and pulling it out and changing it to I, the imaginary number. Then we just have the number left under the square root. Then you simplify that similar to how we've been doing these other ones. Simplify the root and see what you get. So if you look, is there any perfect squares that go into 18? Yeah, 9 is a perfect square that goes in there. So we would say this as square root of 9 times square root of 2. Square root of 9 simplifies to 3. So the answer for this one would be 3i square root of 2. It's an imaginary number answer. Okay. The next one, B. Now this one involves some variables too. That's okay. We still do the same thing. Change this to I, take it out, pull it out as I. Now we want to simplify anything that's left under the radical sign. So is there any perfect squares that go into 125? Yep, 25 goes in there 3 times. So we have square root of 25 times square root of 3. Now we also want to look at variables. How many of those x's, how many pairs of x's do we have in there? Well, if we're thinking pairs, we could simplify almost all those pairs. There's 2 pairs of 4 in there, so we could split this up into x to the 4th and square root of x. This still combines together right here. These combine together still to equal x to the 5th. But what we can do then is simplify one of them. So the ones we can simplify here are this one and this one. These 2 are going to be able to simplify. These other 2 are not. Square root of 3 and square root of x do not simplify. So let's do the ones we can simplify first. Square root of 25 is 5. X to the 4th does simplify. That would end up being x squared. Because if you take the square root, remember there's like a 2 here, where we're dividing 4 by 2, we get 2. We also have this I, it's an imaginary number. Now what's not able to simplify, we put back together under 1 square root. So these 2 other terms stay under the square root sign, and that's our simplified answer. So 5x squared I, square root of 3x. Let's try a few more. All right, on number 10, they want us to do some multiplication here. Before we multiply, though, we want to simplify these negatives. Anytime it's negative, turn it into I here. So we got I square root of 10 times I square root of 15. Okay, I times I, that's going to equal I squared. And then we can combine these, since neither of these simplify, let's combine them back together into one radical. 10 times 15 is 150. All right, now we want to keep going and see, does this simplify anymore? Well, square root of 50, is there any perfect squares that would divide into 150? And there is one, 25. 25 is a perfect square that would go in there. So we know that square root of 50 is square root of 25. And if you divide 150 by 25, you see that it goes in there 6 times. Now let's look at this I squared part. What can we do with I squared? Do we leave it as I squared? No, anytime you have a power of I, you should be able to simplify it. If we go back to our notes that we had before, what we said is that I squared is equal to -1. So going back to our problem, we know I squared is the same as -1. So now simplifying out, we got -1. Square root of 25 equals 5 times the square root of 6. Square root of 6 we can't simplify, so the final answer here, multiplying these 2 numbers together, is -5 square root of 6. So even though we multiply, what's interesting about this problem is we started off with 2 imaginary numbers, and when we multiplied 2 imaginary numbers, we actually get a real number. It's no longer imaginary. You actually get an answer, and this is where imaginary numbers started coming into be useful, and there's lots of applications where imaginary numbers occur in real life, one of them being electricity. There's stuff with electricity, when you do that, that has imaginary parts to it, with current and stuff like that. All right. Why don't, for tomorrow, that one's on there. Why don't for tomorrow, you guys try this letter D out. See if you can try D and see what you get on D. All right, let's look at number 4. On number 4, we're going to now add some imaginary numbers. These are what are called, there's an imaginary part, and there's also a real part. Now, when you combine real and imaginary numbers, this is where this chapter is called complex numbers, or this section is called complex numbers. These are complex numbers. Complex numbers are when you combine together real and imaginary parts. When you're doing these types of problems, what you do is you just combine the real parts together and the imaginary parts together. You treat it like a variable. So if we combine these together, what are our real parts? 6 and positive 1 would combine together to be 7. If we combine our imaginary parts, negative 4i plus 3i would be negative 1i. You could put the 1 if you want, or just I, and that would be the answer. Okay, pretty straightforward. Why don't for tomorrow you try B here and see what you get. B when you, that one's a subtraction one, see what you get when you subtract that. Okay, let's try multiplication one. This one, they want us to multiply two complex numbers. You would do this using our FOIL processor, the acronym first, outside, inside, last. So if you multiply the first thing, 6 times 6, 36. The outside part plus 6i. The inside part minus 6i. And the last part's I times I would be I squared. One's positive, one negative, so it'd be minus I squared. Well, these middle terms are going to cancel each other out, aren't they? Because one's positive, one's negative. So we get 36 minus I squared. Remember, anytime I has a power, we should be able to simplify it down. Well, I squared is the same as negative 1. So doing some more simplifying, 36 minus negative 1 would be 37. Multiplying these two complex numbers actually gives us a real answer of 37. One more I want you to try for tomorrow. Why don't you try one out kind of similar to this. See if you can solve D here for tomorrow. Try that one out and see what you get. All right. Final one here, number 5. It says the base of a parallelogram is half the height. If the area of the parallelogram is 18 inches, what is the length of the base and the length of the height? Anytime you get one of these geometry problems, draw out a picture. Here's our parallelogram. And what they tell us is if this is our height, the base, the bottom, is half the length of the height. So our base equals 1/2 the length of the height. All right, and they say that in this one, the area is 18. Well, we know area of a parallelogram is base times height. So if we put 18 as our area, our base is 1/2 h, and our height is h. Now we should combine together and see what we get here. Well, we got 18 equals 1/2. H times h is h squared. We want to keep solving. If we have a fraction, we can multiply by the reciprocal of 2/1. So if our reciprocals cancel, we got h squared equals 36. Doing a little more solving now. If we take the square root, square root of 36 would be 6. Now really, remember, it is plus or minus when we do this, so it should be plus or minus 6. But we can't have a negative length, so we only use the positive one. So the height would be 6. What is the base then? Plug it back in. If the base is half the height, then our base is going to be half of 6. So our base length is 3. And it both would be in inches. Okay, so if you get a geometry problem, set it up, look at what they give you, solve it out, draw a picture. All right, we'll look at some more of this stuff tomorrow.